Let there be two observers, A and B. Let A and B agree that B should travel at some relativistic velocity v between two arbitrary points in space, P1 and P2. At P2, place a timekeeping device large enough to be visible from P1 where A remains at relative rest. At what time does A observe B reach P2 if they are both using the same timekeeping device? Current models tell us that v in the reference frame of A is not equivalent to the agreed upon velocity v due to the dilation of time, leading to the phenomenon known as relativistic simultaneity, indicating that A and B cannot agree upon the time at which B reaches the clock tower. Let us instead quantize motion such that there exists some finite number of dx quantities per the total distance between P1 and P2. This gives a magnitude of motion that is equivalent in each reference frame relative to the underlying coordinate system. As the observer who is in relative motion is propelled further along our temporal axis, they are propelled into a further dilated coordinate system, describing time as a concurrent density axis. This, of course, aligns itself with the principle of cosmic inflation, but further, we can attribute a direct physical mechanism to the equivalence principle. Let this be Earth. If instead of the lighthouse and the clock tower, we rearrange our experiments so that the lighthouse is at Earth's center and the clock tower on its surface, we should look for the dilation required to produce our gravitational acceleration vector at our radius r. To find the source of this dilation, we should first look for a scalar quantity that can be applied in the same manner as gamma. Let us then define delta to be the derivative of gravitational acceleration with respect to radius. If we then consider that this divergence is likely radial, we should consider the cube root of delta as the inverse of the divergence of a three-dimensional diagonal matrix whose diagonal components are comprised of omega. Here, we find a purely numerical intersection with a fine structure constant, but I believe that I can convince some of you by the end of this video that we can derive a relationship between gravity and electromagnetism through this equation. Let's first explore this relationship by isolating the electromagnetic constants on one side. Let's then swap r over to the other side algebraically. If we then integrate with respect to r, we find another numerical intersection with the square root of the golden ratio to an almost undeniable accuracy, indicating some sort of phase shift at r. We're not done though. This model gives a series of results, all starting from the same principle. The lighthouse and the clock tower are further separated in the coordinate system of B. Let's then consider that we've now reintegrated this quantity to find this intersection at our radius. We should then recognize that these additional components represent the ds portion of gamma. If we then add 1 to the set of components, we find a gamma equivalent quantity that would be induced by our velocity relative to the cosmic rest frame. If we then solve Einstein's equation for gamma for v and substitute in the quantity that we just derived, we find an almost perfect intersection with the velocity required to induce the CMB dipole, but it's not. The derived velocity actually produces a ratio with our observed velocity of 1 plus alpha, the fine structure constant. It must seem like a safer argument to claim that this velocity is just an approximation for the velocity necessary to induce the CMB dipole, but with the frequency with which this ratio of 1 plus alpha falls out of the relationship between derived and observed velocities in this model, I think that it's a reasonable relationship to consider, especially given the accuracy with which we can measure the dipole. We should then pause and recognize that we can do exactly the same process with our gravitational parameters, where our gamma equivalent quantity can be found by the average of the integral of delta with respect to radius. If we again solve Einstein's equation for gamma for v, we find not our kinematic velocity, but our cosmological velocity. Here, in this plot which is borrowed from Determining the Motion of the Solar System Relative to the Cosmic Microwave Background Using Type 1a Supernovae by Christopher Gordon and his colleagues, our derived value falls almost perfectly on top of probability curves found by correlating supernovae data to the CMB dipole. But due to the wide error margins inherent in these types of measurements, we're going to need to do better. To derive our kinematic velocity from gravitational parameters, we're first going to need a time equivalent quantity. This gives a model in which time is a direct physical, measurable process instead of some abstract medium we can't directly measure by attributing time itself to cosmic inflation and gravitational acceleration when observed from different reference frames. Let us start by re-examining the lighthouse and the clock tower. If we consider this quantity, the magnitude of motion in the coordinate system of B, we find a magnitude that represents motion through a static coordinate system in the oven in the common raisin bread analogy. We should then recognize that since we've attributed time to an observable, measurable process, motion must now act as the driving rate of change. This then gives us a time equivalent quantity that is equivalent to the magnitude of the vector accumulated divided by the unit magnitude. In other words, time is equivalent to this divided by this. Likewise, if we integrate this quantity while keeping the denominator fixed at its unit magnitude, or the velocity in units of distance, we find a quantity that is equivalent to time integrated. Now that we've defined this time equivalent quantity, let us apply it to our cosmological velocity equation. This should reduce this density gradient to the coordinate system we experience while in co-motion along this axis. First, we should divide the ds portion of our gamma equivalent function by the velocity which we first derived to produce a per distance dilation. We should then multiply the ds portion of our time equivalent quantity, which now represents magnitudes of motion. This gives us a per distance dilation scaled by the distance traveled. If we then integrate both of these quantities, the radial vector and the distance traveled, we find the following. This again aligns with our kinematic velocity, again following the 1 plus alpha relationship, once more indicating that gravity is a velocity-dependent force mediated by electromagnetic divergence. Let's now go back and review the original relationship to the fine structure constant that we first discovered. As this equation represents the relationship between gravitational acceleration and electromagnetism in a co-rotating frame of reference, we should recognize that this quantity, uppercase gamma, is likely related to spin. Likewise, we should acknowledge that if the divergence of the coordinate system is not zero, then the divergence of the magnetic field is not zero, but is equivalent to this divergence. If the only difference between electricity and magnetism is the orientation of wave propagation as it relates to an equitemporal plane, then the divergence of the electric field in a co-moving frame of reference along our temporal axis should be c times our magnetic divergence. If we then apply our uppercase gamma quantity to produce a co-rotating frame of reference, we find our rotational velocity at the equator to an error of just about an inch per second. Let's now consider this diagram, in which we can derive a stable orbit velocity for an idealized one-body system trigonometrically instead of algebraically. In a Machian universe, where inertia is comprised of the sum of this radiating force for all other bodies in the system, a one-body system should experience zero Machian inertia. Setting up this trigonometric equation gives the following. As we are looking for an equilibrium solution, we should seek to find an orbital velocity that is equivalent to the kinetic energy of the body in motion within the enclosed Machian coordinate system. In other words, as these two quantities remain equal for a body in orbital motion, his inertial state is maintained. It is this equilibrium solution that gives rise to the phenomenon where an inertial state exists at a stable velocity rather than a velocity of zero with respect to the cosmic rest frame. If we then take the quantity that we just found to produce this equilibrium condition and substitute it back into our trigonometric equation, we find the following equation for a stable orbit velocity. If we consider our galactic parameters, where our galactic center overwhelmingly dominates the local gravitational environment, we find a value that precisely predicts our galactic rotational velocity with only visible mass. And where is our sun? It's also important to keep in mind here that mass was not integrated radially to keep the equation in this form. Integrating mass proportionally would improve the curve fit with this observational work carried out by Anna Eilers and her colleagues, represented by the green line. The blue line represents our derived equation, and the red line our Newtonian orbital velocity equation. Let's then recognize that if instead of solving for v and setting dt equal to 1, as we've just done to reach our orbital velocity equation in the coordinate system of b, the observer who is in relative motion, we can simply solve for dt using our Newtonian equations for motion to reach a gamma equivalent quantity in the reference frame of A. As relativity predicts, this value is not quite 1, but slightly higher. If we then apply the same pattern, first solving Einstein's equation for gamma and then substituting in the derived velocity, we find a velocity that once more follows the pattern of 1 plus alpha. Let's now recognize that we can be confident in two properties for our local system. First, that all of our constants are most accurately measured here. Second, that the sun, being the dominant body in the system, is much more massive. This mass discrepancy creates a gravitational gradient that approaches a co-rotating frame of reference for the sun, giving a net d theta approaching a limit of zero. If we consider that this quantity likely acts inside of the divergence, we should look for the cube root of uppercase gamma. Likewise, if alpha in uppercase gamma is a consequence of spin, we should collapse that instance of alpha to 0, leaving us with the cube root of 1/2. This then gives an equation equivalent to that with which we first discovered alpha in the solar frame of reference as follows. Solving this equation numerically gives 1 plus minus alpha to an even greater degree of accuracy than our original equation. 0.0034% when our solar parameters are applied to this theoretical lower limit. This gives a single function that yields alpha and 2 minus alpha for more quickly rotating bodies and 1 plus minus alpha for more massive, slowly rotating bodies. Let's now consider the radius-independent magnitude of this dilatory energy. As this quantity gives units of velocity, we should compare this metric to our orbital velocity. If we then compare this ratio of motion through space with the ratio of static space, we again find the fine structure constant through another numerical intersection. Or if we rewrite this in terms where alpha most frequently appears as a scalar of distance, we find the following, giving an error of just 0.014%. Let me end with some closing arguments, but first I want to say thank you to everyone for taking the time to watch this whole video. When I realized the potential that this model had, I quit my job. I became homeless in the process, but I really feel that the results were worth it. Slowly scrolling is a list of just some of the equations that we derived, mostly from first principles, others from numerical intersections, but all from the same underlying geometry. The Lighthouse and the Clock-Tower are further separated in the coordinate system of B. This combines cosmic inflation, gravitational acceleration, and time itself into a single process as observed from different reference frames, giving what I argue is the single most elegant model of gravity ever proposed. There are no more singularities as they dissipate as an observer approaches that gravitational field, becoming nothing more than a mirage in the distance. This coincides closely with the recent work out of Australia by En-Bong Lee, demonstrating that the speed of light is not constant across a varying gravitational potential. There are no more twin grandfather paradoxes as the chronology is reordered such that the grandfather no longer exists at time t, where the death would occur. He would now exist at time t plus n if he's still around. There's no way I'm going to touch on the potentials of massless constants in this model or how this geometry appears to align itself with religions from all over the world in the very first video. Well, with time now having an explicit geometry and magnitude, almost all known temporal paradoxes fall away. Even such paradoxes as the Fermi paradox offer new possible solutions, as our temporal axis becomes nothing more than a density axis that we are propelled across as a function of motion through space. Likewise, super-evolved galaxies at distances approaching that which currently indicate ages that seem paradoxical no longer produce such paradoxes, as the evolution of time at some distance r from p0 is not necessarily associated with the radial distance. This is made possible by the fact that our beginning is not necessarily the beginning, since this density axis is concurrent. Think about it. If observers A and B in both models share time coordinates at t, and do not share time coordinates at t plus n, this concurrent nature is self-evident. And lastly, we are not relying on the dilation of an invisible quantity that nobody has ever directly measured. Time is now nothing more than a mathematical tool, a ratio of distances in one frame, the dilation of space in another, the gravitational acceleration from the perspective of an observer upon a radiating equitemporal plane. Importantly, this results in magnitudes of ds over dx in both coordinate systems that match observation. A magnitude that matches the Newtonian magnitude for B in the coordinate system of B, and a magnitude that matches the relativistic magnitude for B in the coordinate system of A, but there are fewer limitations produced in the coordinate system of B due to the dilation of variables. I hope everyone keeps an open mind and considers the possibilities. There are no limitations around the creation of mass, only a dramatic misunderstanding of curvature, of which this fourth axis, our temporal dimension, is completely comprised. As there is no limitation around the very large, so too is there no limitation around the complexity of the very small. Distance, not time, is relative, and it's relative to your position along this density axis. In fact, dx ds becomes the constant between reference frames, much in the same manner that Einstein's four vectors maintain an equivalent magnitude. In turn, your position along this density axis is dictated by your motion through space, as described by these coordinate transformations, which is itself just a single modification to Einstein's relativity. The Lighthouse and the Clock-Tower are further separated in the coordinate system of B by a factor of the same magnitude.